No, it's okay. You guys can ask questions. That's the whole goal, to have actual thing. So the first one is the first trig derivative. I'll just go over that. Does it say sine of x minus 2y is equal to, that just says y squared. So yeah, this one we take a derivative of this. So this one has a chain rule and the the implicit derivative. So if I take a d to the dx here, then I should get cosine, because there are two layers. There was a first layer and the second layer. You should see that. So that'd be cosine of x minus 2y, and that's whole thing's gonna be times by 1 minus 2 dy dx, and that's equal to 2y, right? So that derivative is already good. Now you just have to understand this is a quantity itself.
Isn't it 2y dydx?
2y dy dx, yep. Thank you. Dy dx. So then this whole quantity itself, and it's going to distribute here, and the problem is people don't see the distributions, and they don't know what to do here. And some people, as crazy as people actually do foiling, which is kind of bizarre. But it's a cosine of something is distributed to that. So it'll be cosine of x minus 2y minus 2 dy dx times cosine of x minus 2y is equal to 2y dy dx. Now, with that being said, that you're going to have, let's move it to the other side. So x minus 2y is equal to 2y dy dx plus 2 dy dx times cosine of x minus 2y. You can factor out a dy dx. That's going to give you 2y plus cosine of x minus 2y, cosine of x minus 2y, and then you can divide it over, so you're going to get dy dx equal to cosine of x minus 2y over 2y plus cosine of x minus 2y. The whole idea is the second part here is just a pure algebra. Sometimes people don't see is they thought it's distributed to parentheses. That was the first mistake. It's actually cosine of something quantity is going to distribute to both terms. Is that okay? So that's a trig and implicit derivative. Second one, what is a double derivative? Well, the double derivative example, I'm going to give you x squared plus y squared equal to 4. And let's just say they will say find d2y dx2. This means the second derivative. And the second derivative is pretty easy. Well, first of all, you have to understand this equation is actually a circle equation. On the side note for SAT type is x squared plus y squared is equal to 4. That means you have a circle with radius of 2. And that should help you on SAT or ACT because they love circle equations. And that's going to give you like this. Now, if you have x minus 2 squared plus y squared equal to 4, that circle basically move right 2 units because inside a parenthesis, x is going to move right. So usually it's opposite to the sign. So it's minus 2 is moving right 2 units. And if it's a y minus 2 parenthesis squared, then it's going to go up 2 units. So it's opposite direction. Sometimes in SAT, they also ask you, says something like complete the square, says, can you tell me what is this is y squared plus 4y is equal to 11, something like that. Basically, you have to complete the square in this case, so you had to plus 1 on both sides, so it'll be 2 divided by 2 squared, take a middle term divided by 2 squared, 1 squared is equal to 1. So you're going to have to say this is plus 1, and this is plus 4 divided by 2 squared, that's equal to 4, so plus 4. So you can plus 1 and plus 4 here, then that's going to be x plus 1 squared plus y plus 2 squared, that's equal to 16. That means the circle is moving left 1 unit and down 2 unit with a radius of 4. But anyway, this is on SAT side notes. Just kind of help student prepare for SAT if they have PSAT coming up. That's very helpful. Now, if I want to take a second derivative here, let's go back to calculus. Let's take d to the dx. I'm going to get 2x plus 2y dy dx is equal to 0. Does that make sense? Then I'm going to solve for dy dx. So 2y dy dx is equal to negative 2x. And dy dx equal to negative 2x over 2y. So equal to negative x over y. Okay, you got that? Good. So now we're going to do a second derivative, which is d to the dx again. So now I'm going to take a second derivative, d to the dx. Now remember that dy dx is equal to negative x over y. So if I do a derivative of that, this one here, I'm going to use later too. So don't forget about this. And don't forget about this as well. So we're going to use this 2 box later. Okay. So now, let's just say if I want to take d to the dx of a dy dx equal to negative x over y. So that means I'm going to get d2y dx2 equal to low d high minus high d low over low. Now I'm going to change this to black because if I change this to black, I know that one I need to go back and substitute. So I have negative y plus x plus dy dx. We're going to use the first box here, right here. So that is going to give you a negative x over y, all over y squared. Does that make sense? Low d high minus high d low over low. Now dy dx, we can substitute that dy dx. So that's going to give me a negative y. So what happened is I need to combine fractions here. So I'm going to combine fraction by multiply by this by y over y. Does that make sense? Y is going to be negative y squared minus x squared over y squared. And not only that, I'm going to say negative y squared minus x squared over y times 1 over y squared. So keep change flip. That's equal to y squared. I take out negative sign here. It would be x squared plus y squared. Now, if you pay attention to here, this part here, it belongs to original box right here. That's a very bad color. If you're colorblind, you cannot see those. So this thing here, you're going to go all the way to black. So that's just going to be negative 4 over y to the third. So that's my final answer. So to find a second derivative, you need to somehow use the original function and somehow use the derivative function to find out the second derivative. And that should be all. Do you guys have questions?